So next topic is the Norton's theorem. Norton's theorem. So this is lecture 2. Last step we have studied Thevenin's theorem. Now today we are going to study Norton's theorem. So what a statement says that, see here, Norton's theorem statement says that a linear two-terminal network or circuit can be replaced. This is a linear two-terminal network. So we are going to replace this complex circuit, right, by an equivalent circuit. That equivalent circuit consisting of a current source, that is IN. See here, replaced by an equivalent circuit consisting of a current source IN. So it should be in eyes of N. N stands Norton. Okay. in parallel with the resistor Rn. This is the Norton resistance Rn. So this is Rn, Norton resistance, Norton current. Right. So here IN is the short circuit current. Here IN is equal to short circuit current. So what is Rn? Rn is the input or equivalent resistance or the terminals. Okay, on the terminals when the independent sources are turned off. So you know the same like Thevenin's theorem. So when you're going to find the Rn, so what you have to do, you have to just turn off all the independent sources. But what the statement says? A linear two-terminal Norton's theorem statement says that a linear two-terminal network can be replaced by an equivalent circuit consisting of a current source IN, right, in parallel with resistor Rn, where IN is the short circuit current through terminals A and B, and Rn is the input or equivalent resistance to the terminals when independent sources are turned off. Right. Right. Independent sources turned off means what? When we are going to find Rn, so all independent sources must be turned off. Suppose you have a current source. So when this is turned off, it become open circuit. So when voltage source we going to turn off, and the voltage source, whatever, it become a short circuit. It becomes short circuit. That you have to remember. So we do an example on Norton theorem. Let's see that. Find the Norton's equivalent circuit of the circuit shown in figure. Okay. So when you see this circuit here, so this is 2 ampere current, right? And this is 4 ohm, okay? And this is 12 volts, okay? And here I'm going to connect one more resistor, that is a 8 ohm resistor, and here 5 ohm with a 5 ohm resistor. Another resistor I'm going to connect this one with the 8 ohm resistor, right? And here that is a AB. Right. So this is a complex network, a two-terminal network. So what we're going to do is simply replace this network, as the statement says, a current source IN in parallel with RL, that is A, B. So you have to find IN and RN. Right? So I have to find Rn. To find the Rn from this circuit, what I do, you have to switch off all independent sources. So when you switch off, now I'm going to find Rn or switch off all independence. The current source is there, so what happened? It is a short, it is a open circuit. So then there is a resistor and there is a 12 voltage source is there, so that will be shorted. That will be shorted. Right? So this is shorted here, and this is a open circuit, and this is the 4 ohm. You know that. Then there is a 8 ohm is there. There is a 5 ohm is there, and there is a 8 ohm resistor. So this is our A and B, and this is the total resistance we are going to find it. So now what happens, since it is an open circuit, this part can be eliminated. So what is left? Only we have left with a 4 ohm, and this is a 8 ohm, and this is a 5 ohm, and this is a 8 ohm, right? And this is a A and B, this is a R, N. Now see, these three are in series. So 8 plus 4 plus 12 plus 8, 20. 20 ohm. This is a 20 ohm. And there is a parallelly connected with a 5 ohm. Right? 5 ohm. This is a U. So this is a Rn. Now Rn is equal to, what happens? Now the Rn equation is 5 into 20. Since they both are in parallel, so 5 plus 20. So Rn is equal to what happens? 5 into 20 by 25. 25. 5 is 4. So your Rn, so is equal to 4 ohm. Is equal to 4 ohm. So now you got a 4 ohm here. Got a 4. Now I have to find the IN, Norton current. How I am going to find the Norton currents? So let me just erase it. So I am going to find this IN. So you just see that this is the circuit I1, okay, and when you're going to find IN, you have to short it actually. You have to short it, and this is the short circuit current. So that is equal to IN. That you are supposed to find it, right? Now what happened? This one is the I2. This is the I2. This is the I2. Right? So here, when you apply the KVL, so you use the mesh analysis and find I1 and I2. Right? So here I1 is equal to, you know the case, I1 is equal to I2. So I1 current is flowing here. In the loop there is a current source, so I1 is equal to 2 ampere. I1 is equal to 2 ampere. Now in the second loop, when you apply KVL, so what happened? Minus 12. So current is flowing minus 12 terminal. So next to 4, then I2 at the same time I1 current also flowing. So I'm going to put I1 here. Then this is 8 I2 C. So here 5 ohm resistor is actually short, it will become 0. This becomes 0 means this becomes 0 because these both are in parallel. In a parallel, what is the resistance? 0 into 5 by 0 plus 5. Okay, 5 by 0 by 5, that will become 0. So this resistance becomes 0. So what I do, then directly I am going to take it. That will not be taken this one. This one only, then after it will come. This is the 8 I2 is equal to 0. 8 I2 is equal to 0. So minus 12, then 4 I2 minus 4I1. So this is a 16I2 is equal to 0. Right? 16I2 is equal to 0. 4I2, 4I1 this one. This one is a 4I1. So minus 12. This is a 4I2. This is a total 20I2 minus 4 into what is the I1 you already know, that is a 2. So that is a 0. Minus 12 and minus a 20. So 20I2 is equal to this. You take this side, you will get 20. So I2 is equal to 20 by 20. So you will get 1 ampere. 1 ampere. So I2 is equal to 1 ampere. I2 is equal to 1 ampere. You know that I2 current. So since it is 0, I2 current is flowing like this. Right. So here I2 current is equal to short circuit current. The short circuit current is equal to IN. What is the now I2? I2 is equal to short circuit current. See, I2 is equal to what? This I2 current is flowing. This is all the same direction. I2 is equal to short circuit current. That is equal to IN. So that is a 1 ampere. So now what is IN? IN is equal to 1 ampere. So IN is equal to here. We found that is a 1 ampere. That is how we are going to find. This is a total equivalent circuit is this one. Right. Suppose if you want to find any resistance I have connected here. Right. You want to find that short circuit current or how much current is flowing with 2 ohm. So how you are going to find it? Right. So you just apply the formulas and we can find it. Right. So to find IN, you find it to current flowing through resistor. Right. That can be current division rule. You can apply the current division rule and we can find it.